In this video, we're going to look at how to complete the square. Now, I'm not going to go into the big explanation using perfect squares. I'm just going to use a simple method to complete the square in this video. Now, if you want to see my video on how to use perfect squares to complete the square, you can click this card at the top. So in my first question here, I want to write this quadratic x squared plus 4x take away 3 in the form x plus h in brackets squared, so this is my perfect square here, plus a constant k. Of course, h and k are constants. So I'll just write over the question, x squared plus 4x take away 3. And the first thing I'll do is put my brackets for the perfect square. So brackets with the square here. So that's my brackets for the perfect square. My variable is x, so I'm going to write it back. And then I'm going to find half the coefficient of positive 4. And of course, a half of positive 4 is positive 2. So I'll write positive 2 in here. So again, how did I get this number? Well, a half of the coefficient of x. And the coefficient of x is positive 4. So a half of positive 4 is positive 2. So now I have my brackets for the perfect square. I'll write back the negative 3. So write back the negative 3 like this. And now I'll always take away this number here squared. So I'm going to take away that 2 squared. Now notice I put the negative sign outside the brackets because this will always be negative. And whatever number this is, I will simply square it. So now all I have to do is work out this piece here. So 2 squared is 4. So I'll have x plus 2 in brackets squared. Take away 3, take away 2 squared, which is 4. And of course, negative 3 take away 4 is negative 7. So that will give me x plus 2 in brackets squared take away 7. And now I have completed the square. Well, you might be wondering, what is the benefit of changing the form of this quadratic into this form with the perfect square? Well, first of all, the graph for this quadratic would be a minimum curve. If the number in front of x squared is positive, the graph is a minimum curve. So what we have here is 1x squared. If the number in front of x squared is negative, the graph is a maximum curve. So a minimum curve looks like a valley, the maximum curve looks like a mountain. So this graph is a minimum curve, and this negative 7 here would be the y component of our turning point. Therefore, this negative 7 will be our minimum point on the curve. This value 2 inside of here, if we change the sign from positive to negative, will be the x component of our turning point. So I'm going to put 4 the turning point. We'll put this x plus 2 equal to 0. We'll carry the positive 2 across the equal sign and get x is equal to negative 2. So now this will be the x component of our turning point, and this negative 7 will be the y component of our turning point. So my turning point would be negative 2 and negative 7. And as we discussed, the graph would be a minimum curve, and therefore this would be the lowest point on the graph. So this turning point would be a minimum. So I'm just going to write that the turning point is a minimum. So after completing the square, you could be asked questions like, what is the minimum or maximum value of y? Well, this negative 7 here would be the minimum value of y. Now, the question is say minimum or maximum because they're testing to see if you know if the graph is a minimum or a maximum. Okay, so the number in front of x squared is positive, the graph is a minimum, so this value here would be the minimum value of y, which is your y component of a turning point. Then they could ask, what is the corresponding x value? And this negative 2 would be the corresponding x value, which is the x component of your turning point. So now I'm going to show you what this minimum curve looks like with this turning point. All right, so here we have our curve, which is a parabola. You see it's going down like a valley, which is a minimum curve because the number in front of x squared is positive. I simply label my function f of x is equal to x squared plus 4x take away 3, which is this quadratic here. We can see our turning point down here, which is the lowest point on the graph, which would be negative 2 on the x with negative 7 on the y. Negative 2 on the x, negative 7 on the y. Now, I have another point here, which is 0, negative 3, which will be the y-intercept of the graph. Now, the y-intercept is easy to find. It is the constant on the quadratic. So this negative 3 here would be our y-intercept. Number 1 then, well, how did you arrive at this negative 3 being the y-intercept? Well, whenever x is 0, that's when you'll get the y-intercept for any graph. Okay, so let's look at that. I'm going to put 4 y-intercept. X is equal to 0. So if I were to put y is equal to my function, which is x squared plus 4x take away 3, and maybe one then, well, I have f of x here is equal to the quadratic, and here I put y is equal to the quadratic. Well, y is equal to f of x. So you see for the y-axis, I put f of x. Well, the y-axis or the f of x-axis mean the same thing. So I can replace this y with f of x, or I can replace f of x with y, means the same thing. So now when I substitute x is equal to 0, I'll have y is equal to 0 squared plus 4 times 0, take away 3. Now 0 squared is 0, 4 times 0, anything times 0 is 0, take away 3, and as we know, 0 is nothing. So I'll end up with y is simply equal to negative 3. So this is the way it goes. When x is 0, y is negative 3. Say write that as a coordinate. X is 0, y is negative 3. And this is our y-intercept. And that's why I have 0, negative 3 here, which is this point, as our y-intercept. Now, there are a lot more details I could put into this graph, like the x-intercepts. I could give you a specific domain and ask you to draw the graph for that domain. But we'll look at those things in another video. For now, we're keeping it simple, just completing the square, get the turning points, and showing you what it looks like on the graph. So here I have my second question, which is to write this quadratic. Now notice the difference here. I have negative x squared. All right, I have the same positive 4x and negative 3. So let's look back here. See, x squared plus 4x take away 3. But this time I have negative x squared plus 4x take away 3. So the only thing I changed was this negative sign in front of the x squared. Now look at the form. I change the form now. I put a in front of the perfect square. We have the same x plus h in brackets squared plus k, but we have this additional a, and that's because of this negative sign in front of the x squared. See, look here, we just have x plus h in brackets squared plus k. All right, this was the form. But here we put a, x plus h in brackets squared plus k. And this a is because of this negative sign. Now, how do we do this? Well, let's write over the question first. So we have negative x squared plus 4x take away 3. Now, before I can use the method that I showed you in the last question, I'll have to get x squared by itself, meaning I need to get rid of this negative sign in front of the x squared. So how do I do that? I do that by factorizing. So I'm going to factor out the negative sign. So I'm going to put the negative sign, I'm going to open brackets, and then I'm going to say negative x squared divided by negative sign, which will give positive x squared, positive 4x divided by this negative sign, which will give negative 4x, and then negative 3 divided by this negative sign, which will give us positive 3. And now I close the brackets. And now that I have x squared by itself like this, I can use the method that I showed you in the last question. So we're going to open our brackets for the perfect square. X is my variable, so I'm going to put x here. I'm going to take half the coefficient of x, and this time the coefficient of x is negative 4. So half of negative 4 is negative 2. So I'm going to write negative 2 here. I'm going to bring back down the positive 3, so positive 3 here. And then I'm always going to take away whatever number we have here, we're going to square it. So again, we're going to take the 2 and square it. Now notice this is always take away here. Don't matter if here is negative or positive, this is always take away. And whatever number we have here, we're going to square it. So now just like before, we're going to square 2 and get 4, and then say 3 take away 4. So I'm going to have x take away 2 in brackets squared plus 3 take away 4 because that's 2 squared. And 3 take away 4 is negative 1. So I'm going to have x take away 2 in brackets squared take away 1. Now, we still have to deal with this negative sign outside here. So in the beginning, we factor out this negative sign by dividing each term in our quadratic by this negative sign. So let's put it back in. Put the brackets. And put a negative sign on the outside. So now to reverse that process, remember we divide each term in our quadratic by this negative sign. So the reverse of that would be to multiply by negative sign now. So when I multiply this negative sign by this x take away 2 in brackets squared, now because of the square, I cannot multiply negative sign by the x and the negative 2. The square preventing us from doing that. So what I'll write is the negative sign, open brackets, x take away 2, close brackets, squared. And when I multiply this negative sign by the negative 1, we will get positive 1. So now we could see that we wrote our quadratic in this form with a being the negative sign on the outside, x plus h in brackets squared plus k. Now you're probably wondering, well, a is supposed to be a constant and I just have a negative sign on the outside. So that's not a constant. Well, the negative sign is standing in for negative 1. So really and truly, there's a negative 1 on the outside. All right? And what you're multiplying by is negative 1. Well, it's understood. Let's put the negative 1 here. So it's understood to be negative 1 here. So you don't necessarily write it. You can leave it as the negative sign. So now let's look at the graph. So we know there's a negative sign in front of x squared. So the graph is going to be a maximum, meaning it's going to go up like a mountain. And the y-intercept will be this negative 3. Now let's look at the turning points. This positive 1 will be the y component of our turning point, which will be the maximum point on the graph. And the corresponding x value will be this number here. That's change the sign from negative to positive, right? So my turning point would be the x component. You look at this number inside the brackets and change the sign. So it's negative 2, change it to positive. So positive 2. And then take this number on the outside here, positive 1, which would be the y component of our turning point. And now this turning point is a maximum. So let's put turning point is a maximum. So now if a question asks you what is the minimum or maximum value of y, now you see there's asks minimum or maximum because they want you to tell them whether it's a min or a max. All right, so the maximum value of y, because negative sign in front of the x squared, so it's going to be a maximum, will be this number here. So the maximum value of y is 1, which is your y component of your turning point. And the corresponding x value will be this 2 here, which is the x component of your turning point. So here I have my drawing for my quadratic. You can see the maximum curve is going up like a mountain. We can see our turning point here, 2, 1. So 2 on the x with 1 on the y. See, 2, 1 here, 2 on the x, 1 on the y. It's like a mountain, so it's a maximum, so maximum curve. And the y-intercept, which is here, is just this number here. So negative 3 would be the y-intercept. So it means 0 on the x and negative 3 on the y. So I have 0 on the x, negative 3 on the y. This is where the curve touches the y-axis, the y-intercept. So now let's look at this question where we want to write 4x squared plus 12x plus 8 in the form a, x plus h in brackets squared, so this is the perfect square here, plus k. So first let's write over the question. So 4x squared plus 12x plus 8. Now in order to use the method, I'll have to get x squared by itself, which means I'll have to factor out the number in front of it, which is 4. So whatever number you have in front of x squared, you're going to divide everything by that number. So I'll put 4 out here. I would open brackets, and now I'll divide each term in my quadratic by this 4. So 4x squared divided by 4 is x squared. 12x, well, a positive 12x divided by positive 4 is positive 3x. And positive 8 divided by positive 4 is positive 2. And now I'll close my brackets. So now I'll focus on what's inside this bracket here. So I'll put my brackets for my perfect square. The variable is x, I write back x. I would find half of the coefficient of x. And now the coefficient of x is positive 3. So if we look at that, half of, so as a half multiplied by positive 3, which is 3 over 1, and that will be equal to, well, 1 by 3 is 3, and 2 by 1 is 2. If anything could have cancelled, I cancel it. So half the coefficient of x, half of 3 is 3 over 2. So I'm going to put positive 3 over 2. This will be half my coefficient of x. Then I'll write back the positive 2. And remember, we always take away this number squared. So that number is 3 over 2, and we have to square it. So now I'll work this out, and we can do that on the calculator. So I can simply type in the positive 2 take away open brackets 3 over 2 in brackets squared. So I'm going to press 2, take away, I'm going to open brackets, I'm going to use the fraction button and put 3 over 2. I'm going to close the brackets, I'm going to use the x squared button to square it. Press equal and we get negative 1 over 4, negative a quarter. So I'm going to write x plus 3 over 2 in brackets squared, and this works out to be negative a quarter. Now I'm going to bring back in the 4. So I'm going to put my big brackets. I'm going to put back the 4 on the outside. And now to get rid of this big brackets, because I divide everything by 4 to get this, now I have to multiply everything by 4. So when I multiply 4 by this in brackets here, because of the square sign, I can't say 4 by x and 4 by 3 over 2. So I'll have to write 4, open brackets, x plus 3 over 2, close brackets, squared. And then when I multiply the 4 by this negative a quarter, let's see what we get. That's 4 multiplied by negative a quarter. So that's actually 4 over 1 multiplied by negative a quarter. Notice the 4s will cancel out each other. Of course, you're multiplying a positive by a negative, so the answer is negative. And all you have is 1 here, 1 here. So 1 by 1 is 1, 1 by 1 is 1, which is 1 over 1, which is just 1. So we'll have negative 1. So this 4 by negative a quarter will just work out to be negative 1. So now we have our quadratic here in this form where a is 4, the h is 3 over 2, and the k is negative 1. Of course, this graph is a minimum because the 4 is positive, so the number in front of x squared is positive. So we have a minimum curve. Our turning point would be change the sign on this number, so negative 3 over 2 for the x component and negative 1 for the y component. So I'm going to write that. My turning point is negative 3 over 2. See, change the sign on it, positive 3 over 2, right? So whatever this is, just change the sign on it, and that's the x component of a turning point. And the y component is the negative 1. And of course, my turning point is a minimum. So again, if they ask for the max or min value of y, you'll say the minimum value of y is negative 1, and the corresponding x value is this negative 3 over 2. So here I have the drawing of the graph. So we have f of x is equal to 4x squared plus 12x plus 8. That's my quadratic here. Now for my turning point, it's sort of difficult to see where 3 over 2 is if you leave it as 3 over 2. So we'll convert 3 over 2 to 1.5. Just press 3 divided by 2 on the calculator and you'll see 1.5. So I'll just show you that. I'm going to put 3 divided by 2 and we get 1.5. So negative 3 over 2 will just be negative 1.5. So that's why I have my turning point here as negative 1.5 and negative 1, which means negative 1.5 is in the middle of negative 1 and negative 2. So you see it's fall within the middle here. We have 1, 2 little blocks and then a half. So 2.5 little blocks. That's how we get the 1.5 here. And then we have 2.5 little blocks on this side. See, 1, 2.5. So negative 1.5 is in the middle. And then the y component is negative 1. Then we know this number out here, positive 8, is our y-intercept, and the y-intercept occurs when x is equal to 0. So we have 0 on the x and 8 on the y. And of course, our graph is a minimum, so it goes down like a valley, because the number in front of x squared is positive. Now I'll do other videos on completing the square, which will go more into details in terms of the x-intercepts, the range, the domain, and how to draw the graph for a given domain. Okay, so I'll leave that for another video. Just keep it simple here, simple sketch, and how to complete the square. So that will bring us to the end of this video, and I'll see you in the next one.